Hello, today we're going to be going over completing the square method. And this is a really helpful method to use when you're given the standard form of a polynomial equation and want to change the way it looks in order to graph or solve the problem. So, how this goes is you'll see your equation, ax squared plus bx plus c. And when you're completing the square, you're going to isolate this b constant, divide it by 2, and square the entire thing to get another constant. We'll just call it d. And then, say this is equal to 0, you'll add d to both sides, and by doing so, you will have an equation that is factorable. Now, an application of using the completing the square method is to solve problems when the equation is factorable too, but I find that this is not the easiest way to go about that. And if you're able to factor your equation by just using the a, b, and c that you were given originally, you should go about things that way. But as I mentioned before, this can be really helpful if you're given, say, the equation of a circle that is in standard form and you're not really in the mood to create a table and plug in all of the points. If you complete the square, then you will get a much easier form to decipher. So without further ado, let's get into some examples. All right, here I have two problems completing the square. We're just going to start with this one here. All right, as you can see, we have x squared minus 14x plus 30 equals 6. Now, if we were solving this like normal, you'd maybe subtract the 6 from both sides to get x squared minus 14x. And then after subtracting 6, you get plus 24 equals 0. Your next step might be to break up this 24 into a factor that adds to negative 14. You think maybe negative 8 and 3. Not quite. Maybe negative 12 and 2. Yes, that would work, but in this case, we're going to try to complete the square. So, what you would do first is isolate this b, negative 14, and we're going to divide it by 2. And that will give us negative 7. Now we're going to take that and square it, and that will get us 49. Now let's go ahead and rewrite this by adding our 49 to each side of the equation. X squared minus 14x plus 49 plus 30 equals 6 plus 49. And then we're just going to want our nice pretty equation here on the left, so we'll move the 30 over as well by subtracting 30. Now let's combine our like terms on the right side. X squared minus 14x plus 49 equals, let's see, 49 minus 30 would be 19 plus 6, that would be 25. There we go. So now let's go ahead and tackle what is on the left side of the equation here. Since we have x squared minus 14 plus 49, the magic number here that we're looking for is -7, as it squared equals 49 and minus another 7 would equal -14. So when you're factoring this, all you have to do is take your x, subtract 7, and square it. Because if you were to multiply this equation out, you would get this up here. And then we have our 25 on the other side. That is the square completed right there, but we're going to go a step forward and solve this equation. The step to do this first would be to square root both sides. And since this subdivision of the equation has a cubed, we just have to get rid of it. And it will leave us with x minus 7 equals the square root of 25, which is 5. And make sure to add a plus or minus here, since we added this root ourselves. And 5 squared would equal 25, just as -5 squared would. Now we're going to add our 7 over here. And that will leave us with 7 plus or minus 5 as our answer after completing the square. And yes, you could find this by going and using different factors, but completing the square is an alternative way to go. Now, we're going to take a look at this problem. So let's begin by finding our b. That will be -6. Now, let's divide it by 2. That would give us -3. Now let's square it. That is 9. Now look at that. We already have a 9 as a constant right here. So we don't even need to worry and can immediately skip to this step right here, rewriting the left side of the equation. So we'll notice what can be multiplied to get 9 and added to get -6 is -3. So we're going to have x minus 3 squared equals 25. We'll go about these same next steps, square rooting both sides. That will leave us with x minus 3 equals plus or minus 5 again. Adding our 3 to the other side would give us a final answer of 3 plus or minus 5. Now, I want to examine this equation again. I'm just going to move it down here. Let's say this equation was reworded and we had x squared minus 6x, and the 25 was already moved to this side. So we'd have -16 as our c constant equals 0. Now, this wouldn't be so easy to complete the square, but we're going to do it. So find our b. We actually did the same very work up here, so it's going to be plus 9 to both sides. And excuse me for a moment. So sorry. So we've added 9 to both sides, and that will give us x squared minus 6 plus 9, minus 6x, excuse me, plus 9. And then the thing that's left out is our negative 16, which we'd end up moving over to the right, which would give us 25. And you'll notice that this already looks very similar to the equation we worked with on the top, because when you would condense the left portion of the equation, you'd get x minus 3 squared. And then that is the exact equation we had up top. So no matter when you meddle with the right side of the equation, you would still get the correct answer when you're completing the square. All right, now we are going to look at an application of completing the square that I discussed at the beginning of the video, and that is dealing with the equations of circles. So as you can see here, we have a format of a circle equation on the left. That will be x minus h squared plus y minus k squared equals r squared. In this case, h would be the x coordinate of the center of the circle, k would be the y coordinate, and r would be the radius. So from this little form of the circle equation, you'd have everything you need to graph the circle, whereas in standard form, you'd take a look at it and wouldn't be able to immediately decipher the radius and center, just from looking at the constants in that equation. So when you're given an equation in standard form like this, something you'd like to do is complete the square to get it in this h and k form, so you'd be easily able to graph. So let's begin, and don't be intimidated by the existence of two variables here, because we're going to break it down just as you would with a single variable equation. I'm going to start by sorting the x's and the y's together. X squared minus 4x plus y squared plus 2y, and then I'm going to bring this negative 4 to the other side, giving us equals 4. So we're going to do completing the square twice here, and our extra value will be added here for the x, here for the y, and here for the x and y again. So let's start taking a look at the x side first. Our b is negative 4, so we're going to start by dividing that by 2, which will give us negative 2, and then that squared is 4. So this is going to be plus 4. And I'll go ahead and add it over here as well. Now our y, we'll just do it over here. Our b is 2. Dividing this by 2 will leave us with 1. And 1 squared is just 1. So we'd add 1 here. And on the other side as well. Now we're going to condense both the x and y sections of this equation and simplify our right side. I'll do that first and get it out of the way. 4 plus 4 is 8 plus 1 is 9. Now, condensing the x portion, we have 4 and negative 4, and what would multiply to 4 is negative 2, and that would work here in terms of addition. So our magic number here is going to be negative 2. And remember, this is a polynomial, so in order to get it that way, we are going to have to square it. Next, for our y portion, our magic number is going to be 1 because it multiplies to 1, and 2 1s add to 2. So it's going to be y plus 1. And now you'll notice that the equation looks very similar to the circle equation here. As you can see, we have our x coordinate, which is going to be 2. You have to remember that it is made negative. So if the constant appears negative in the equation, the center of the circle will still be positive. And it's vice versa here. The 1 is positive, meaning that in a real circle, the center would be negative. And then our 9 is equal to r squared in this case, and luckily 9 is a perfect square, making our radius 3. So I bet you can imagine that graphing this circle would be far easier than it would be going directly from standard form to your x and y axes. That is going to be it for completing the square today. I hope that this video helped clear some things up, and I apologize for the phone ringing. That is all I have today. Thank you.